Okay, good morning, everyone.
Good morning.
Okay. Are you there? Still can't hear you. Okay. So I'm not sure if the volume in the room is okay, because I can put my own volume, otherwise we'll have some feedback on the audio. So let's just check. Okay, so let's begin and see make sure if the volume is okay. Can you just confirm that you are listening to me?
Yes,
We can hear you clearly.
Anyone?
Yes, I can hear you.
Okay, I can hear you, but give me just one moment. Só estou a conseguir ouvir com o meu microfone, com o meu áudio. Com o meu... Não.
Deve ser aqui a pouco um zero. Ok.
Okay, can you say something again, please?
No.
Yes.
Yes.
Can you hear us?
Yes, I can hear you.
Okay, we're just trying to sort out the audio issue because we can't. Eu uso assim para falar.
Ou venho aqui. Eu não tenho cheiro. Já. Conheço, deve ser o professor Sandro.
Aí, não sei aqui. Falta outra sala.
É o cheiro. Eu não estou.
Eu só posso ver nesta.
Eu sei.
Okay, so hopefully everything is good now, so we can begin our session from the general track. We have 5 presentations, and I believe Claudio is the first one and is ready to begin. So, Claudio, you're free to go. Welcome.
Okay. Thank you for introducing me in the ICCSA conference. So I am Claudio Shepke, and this work was developed with Luis and Pedro, performance and resilience evaluation of hybrid edge cloud IoT system across connected offline and recognition scenarios. We are from Brazilian, from south of Brazilian, from Federal University of Pampa. And so our problem, we identify that some properties, raw properties, have problems with irrigations. And this is the most case for small producers. And some context, some problems that we found, it's that for irrigation, there are power outages, water supply interruptions, and requiring cross losses. And there are solutions we found in the literature that can solve and control this automatization, but there are significant costs involved and a complexity in terms of adopt these solutions. So, in terms of objectives, we develop a smart IoT irrigation solution, and the objective of this solution was the reliable operations, even with unstable internet connections. The solution are low cost. The idea is to help in the usability of the solution and to adopt to any kind of productions for any kind of rural producers. And the solutions involves a hybrid cloud edge IoT system. We can use this system online and offline. That it's automatic to use when we not have connections with internet, and these monitors can help to the control the environment and also control automatically the effects to irrigations in open areas. And we focus in a low cost and usability characterizes. In terms of development of this work, we conduct it like we can see here in this slide with many steps. Firstly, we begin with a study of this field and identify clearly the problems. We collected the initial requirements, and then we design ideation phase and propose initial prototyping. After this, we develop using the ideas of design thinking approach, structuring your project in 4 steps. these 4 implementations are 4 iterations that you evaluate the literature review, we model the concept, we evaluate security aspects, and then explore the study and apply some distributed systems concepts to the end, propose the final solution. The architecture, it's distributed then among cloud, edge, and IoT devices, and our implementations are modular using Django, and the structure is composed mainly for 5 modules. It's likely to see here in this image. We have in terms of the side of the cloud components, we have the container developed with these 4 modules: the irrigation, the telemetry, the core, and the monitoring tasks. These steps have aspects related to the cloud side, and over this container we have also a web container that apply for applications. And in the other side of this C4 model, level 3, we have the edge components that access the irrigation, telemetry, core, and monitoring application. And we developed to access these edge components using the MQTT, the NanoMQ broker, and NanoMQ HTTP server plugin, so we can access the IoT sensors and all modules related to the IoT devices to receive the commands and to send commands to the controller of the irrigation. In terms of tests, computational tests, we evaluate, for example, the constance request rate. We test 1,000 HTTPS requests, and this request has some times from rates, 50 milliseconds, 100 milliseconds, and 250 milliseconds. And we evaluate 3 XTOR devices, SD card, IMMC, and NVMe SSD, and we evaluate throughput and latency as performance metrics. Evaluating these 3 kinds of storage device, only the store device we change in terms of experiments. Then we have the cloud server that is a IaaS implementation. We access this by internet. We have a edge server that is composed by a Orange Pi 3B model with 6 giga RAM, and then we try conditions of storage. And to access the IoT devices, there are 2 ESP32 sensors and actual models, and we connect it with using the MQTT. And evaluating then the storage devices, we have for the 3 conditions, the 50 milliseconds, 100 milliseconds, and 250 milliseconds. And we can see here the throughput in terms of message per seconds, that the NVMe SSD has the better drawbridge for all three conditions. And in this occurs for all scenarios. These different performances increase under higher requested rates, and the star performance directly affects edge processing capability. So we can conclude also that SD cards show it the lowest sustained throughput. In terms of latency distributions, we have here the time under 2 milliseconds for the cloud edge system, and for the edge cloud, number around 8 milliseconds. This cloud edge achieves a median latency of 1.2 milliseconds, and so as we can see, the edge to cloud it's around 8 milliseconds due to the additional processing necessary. There are also significant low variability, indicating that it's stable and the communication is predictable. In terms of resilience evaluations, we propose architecture, and it demonstrates operational during internet outages. The service in the site of the edges continued executed locally, and then after a reconnection, we can have data synchronization and extending the connectivity and evaluating the operations. So in experimental tests, we have continuous local operations. It's no problem with the interruption of the connections, and the systems has a recovery after connections, and then the synchronization occurs. So the operations of these steps, for example, can be illustrated here in this image. Sometimes internet fails. In our experiments, we force this context, and then the offline module has autonomous control of the edge operation. The information of this processing is stored locally and controls the regression operations. And after restoring the internet connections, we receive local informations. We need to understand that after a large moment of internet fails, it's necessary. In our case, the software can control, but sometimes that it's rural producers can check locally what are occurring. It can be another problem. It's not only internet fails, but other problems, physical problems can occur. But in terms of software, we can resolve the conflicts and update the cloud state. So we develop a resilient solution for this scenario. It has many details, technical details, and the project challenge regarding replication. We have data consistency and tolerance for connection failures. We developed it in an iterative approach because we understand that it's a distributed, we can scale our architecture, and also we adopt security aspects to propose the functional operations in connection outstage. And in terms of future works, the solutions it's stable and can be improved using, for example, the usability of the system, and consider other irrigation bases and adaptations for any kind of crop characteristics. So I end my presentation here, and I'm open for questions.
Thank you, Claudio. Can you just close the presentation, please? So, are there any questions about this presentation? Okay. It seems I'm going to make a question. So I was just wondering, in your presentation, you mentioned, actually gave some detail about uh, the storage, data storage systems, and the comparison between different types of storage, and also design thinking. And I was just wondering, I mean, why were those 2 points, specific points, relevant to to your work, that you see them as something that was important to mention? Because the storage system is something that you could easily replace, and so I wasn't sure that it's really critical. And design thinking is quite a different paradigm when you seem to have more like an engineering paradigm here in terms of developing the system.
Yes, I think I understand your question. Yes, the design thinking was more adopted in terms of the all steps of the project. Here for these presentations, we understand to explore more these physical aspects, because the work are more we have the design, and in the other side we have many technical points in this side of these IoT points. It's a more technical, but in terms of modules, in terms of schema, the XChem for example, for the develop H steps, we need a way, we need an idea as how we can compose all these models. For example, here in the edge side, I show only this side, but we have the other component here, the container, the Rabbit MQ, and this is related. It's a shower model, and this access, for example, the side of the internet. So the idea to use design thinking is more about the concepts of the initial idea and how we can propose models in terms of construction of the software.
Okay, so thank you very much, Claudio.
Okay, thank you for your attention, Rui.
And we now move to Christian, our second speaker.
Good morning.
Good morning, Christian. You can begin and share your presentation with us.
Okay.
Excellent.
That's okay. Can you see my?
Yes, that looks good.
Yes.
You can.
Let's start. Let me. Good morning, everyone. My name is Cristiane Ramos. Today I will present our work in Gamifying Science Communication and Experience Report of Jornada Galáctica at Canal Ciência. This research is a collaboration between University of Brasilia and Brazilian Institute of Information Science and Technology, known as IBICT. The project was developed in partnership with Canal Ciência, a Brazilian public science communication initiative. Together, we designed, implemented, and evaluated a gamification layer to increase users' engagement. This is the roadmap of my presentation. First, I will explain the problem that motivates the research. Then I will present our research objective and methodology. After that, I will describe the 7-phase process used to create Jornada Galactica. Next, I will explain how we designed the gamification and how we evaluated it using goal question metric approach. Finally, I will present the main results and conclude with future directions. Science communication portals usually offer a large amount of valuable educational content. However, providing content is only part of the challenge. Many users visit only 1 or 2 pages before leaving the portal. Therefore, the main question is not only how to attract visitors, but also how to keep them engaged over time. Canal Ciência is one of the main Brazilian public initiatives for science communication. In this research, we investigated if gamification can increase user engagement while encouraging users to explore more scientific content. The objective of this research is to design, deploy, and evaluate a gamification layer called Jornada Galáctica for the Canal Ciência portal. Instead of proposing isolated game elements, we developed a complete process that connects design decisions with measurable outcomes. Our work makes 3 main contributions. First, we propose a structured 7-phase process that guides the development of a gamification project from context analysis to continuous improvement. Second, we introduce a goal-oriented evaluation model based on GQM, goal question metric approach, allowing every metric to be linked to a specific evaluation objective. Finally, we present the first results from 2 measurement cycles, providing evidence about users' engagement and help improving the gamified experience. Let me now present our proposed solution. This is our process with 7 phases that guides the life cycle of a gamification project from the initial problem analysis to continuous improvement. The first 3 phases focus on design. We begin by understanding the organizational context, identifying the target audience, motivational profile, and designing the narrative missions, keywords, and progressions goals. The next 2 phases focus on development. We implemented the gamification layer, deploy it in the production environment, and collect user interaction data. Finally, the last 2 phases focus on evaluation. We use the GKM approach to analyze the collected data and identify opportunities for improvement. An important characteristic of this process is that it is interactive. Each measurement cycle generates new evidence, allowing us to refine both the gamification design and the evaluation model over time. Yes. Well, before designing the Jornada Galáctica, we first wanted to understand who our users were And what motivated them? To identify the user's motivational profile, we used the Octalysis framework together with the intrinsic motivation inventory. We combined the two complementary sources of information. The first source of data came from 16 domain experts involved with Canal Ciência. The second came from 581 students representing the portal's target audience. After combining these perspectives, we identified the three dominant motivational drivers. The first was creativity, feedback, represented by Core Drive 3. The second was social influence and relatedness. The third was scarcity and impatience. These findings directly influenced the gamification design. Instead of creating isolated badge points, we developed a complete space exploration narrative in which users progress through 12 sequential missions inspired by the hero's journey. This experience report that I'm presenting now is about the first mission named Looking at the Earth. From a software engineering perspective, Jornada Galáctica is implemented as a gamification layer integrated into the Canal Ciência portal. The portal runs on WordPress. GamePress manages points, badges, ranks, and user progression. Forminator to manages quizzes and missions forms. Every relevant user action generates an event. Reading content, completing quizzing, submitting forms, and finishing missions all generate measurable events. These events update the user's progress and are stored for later analysis. This event-driven architecture connects users' behavior directly to the evaluation model that I will present next. Once the gamification layer was deployed, we need a systematic way to evaluate it. We adopt a goal question metric. At the first level, we have the goals and then questions to answer the goal and metric connected to it to answer each question. Instead of collecting isolated metric, each metric answer a specific question and each question supports a measurement goals. We defined two complementary goals. The first, evaluate the gamification, focusing on motivation, engagement, and user progression. The second, evaluate the portal, focusing on user interests, navigation, and traffic sources. The structure helps connect every metric to an improvement decision. Now I will talk about the results, answering the questions of each measurement goal. Let's now look at the first evaluation results. First question was about the user's motivation profile. Using Octalysis, we identified the three dominant motivational core drives: creativity, feedbacks, and social influence, and scarcity and patience. In future measurement cycles, We will update this motivational profile using data collected from real users. Our second question was about users' engagement. Most users successfully started the journal. 85% reached level 1, about 13% reached the intermediate level. However, only the 2.38% completed the entire journey. These results show that the gamification attracted users successfully. However, keeping users engaged until is until the end of the journey is still our main challenge. About the question 3 and 4, I will talk now. Question 3 was about users' interest. The most popular content was biographies of Brazilian scientists, science communication articles, and history of science. This interest remained stable during the second measurement cycle. Question 4, evaluate portal usage. Compared with the baseline, users spent more time interacting with the portal. The average engagement time increased from 27 seconds to 2 minutes and 20 seconds. The average section's duration also increased from 1 minute to 2 minutes and 18 seconds. This result suggests that users engaged more deeply with the portal scientific content. Finally, we analyzed where users came from. They come from Google. Google remained the main source of traffic. Direct access became the second most important source. We also observed the new traffic sources, including Linktree, ChatGPT, Wikipedia, and educational platforms. These results suggest that the portal reached the users through a wide variety of channels. Our first deployment also helped us identify opportunities for improvement. On the positive side, we can see that users spent more time interacting with the portal and the gamification successfully attracted users. However, we also identified several opportunities to improve the experience. Some missions require longer reading activities, so we plan to simplify them. We also plan to add more social interaction and update the motivational profile using data from real users. Finally, we will continue to the measurement cycles to evaluate the impact of this improvement. And this interactive process is an important characteristic of our proposal. In conclusion, this work presents more than a gamified application. It proposes a complete process that connects motivational analysis, gamification design, and goal-oriented evaluation. Our first deployment showed that the gamification can increase user interaction with scientific content. At the same time, it also revealed opportunity to improve long-term engagement. Our future work will focus on refining the missions, updating the motivational profile, and continue the measurement cycle. I think that our main contribution in this research until now is not on the gamified application itself, but also a repeatable process for designing, implementing, measuring, and continuous improving gamification process. Thank you very much for your attention.
Okay, thank you very much, Christian. So, would anyone like to place any questions to Christian? Oh, I'm going to place one. Okay, so Christian, can you tell us a bit more about the motivational part? So, you mentioned that there was some attention to the motivational part, so why people go there. But in the end, it seems to be all about time. And so I was just wondering if how this motivation actually affected work. For example, if you know that people go to the portal because they want to accomplish something specific, did you manage to adjust the portal to somehow address these concerns better?
I don't know if I understood your question, but I have we are worried about the motivation because Canal Ciência it is used for different kind of people, children, teachers, researchers, everybody can use this portal. So we need design a gamification is that motivate different kind of people. We have all the country use this channel. So we invest a lot of study and time trying to understand our target audience. You understand?
Yeah, okay, that's fine. I was just trying to understand if the motivational part was somehow addressing these different motivations that those different users may have to address the portal, because that would probably make their visit more meaningful, because it would be more
Yes.
tailored to their needs, to what they're actually trying to accomplish. But that's okay. I think we understand your answer. Okay, thank you very much, Christian. So we are now moving to the third presentation with Abdella Naini. Are you there?
Hello.
Hello. Good morning. So if you're ready, you can start sharing your presentation.
Yes, for sure. Is the voice clear?
No.
Could you hear me?
No, it's not yet. Okay, that looks better. Okay, looks good. So
Thank you.
if you're ready, you can begin.
So, good morning, everyone. My name is Abdullah Jnaini, and I'm a doctor in computer science from Muhammad First University, and today I'm presenting a paper that concerns membership inverse attack against knowledge graph. So, talking about knowledge graph or the context, we should know that knowledge graph is a way to organize information. It connects different things together using relationships. For example, we can have three elements: Paris and is the capital of, and France. In this case, Paris and France are objects, and is the capital is the relationship between them. So a knowledge graph is like a big network of connected information. It helps computers understand not only data, but also the meaning behind the data. So knowledge graphs are very useful because they make information easier to search, analyze, and connect instead of storing data separately. They show how things are related to each other. There are many applications of knowledge graph. One important application is search engine. For example, we search for a famous person. Google can show information about their age, job, family, and important events because this information is connected in a knowledge graph. Another application is like a recommendation system, like a platform like Netflix, YouTube, or online shopping website can recommend movies, video, or products based on relationship between users, items, and performance. Also, it's used in medicine. They can connect diseases, symptoms, medicines, and patients. This can help doctors find useful information and support medical decisions. So, to conclude, knowledge graphs are powerful because they connect information in meaningful way. They help machines understand the relationship and and make better decisions. However, knowledge graph can contain sensitive data, such as personal information, medical data, financial data, or private relationship between people and organization. Because of this, we must protect knowledge graph from different attacks and make sure that private information is not leaked. One example of this type of attack is inverse attack, where an attacker tries to reconstruct hidden private information from the model. And we have also property inference attack, where an attacker tries to learn secret properties about the data used to train the model. And in our presentation, we will focus specifically on membership inference attack, where the attacker tries to know if a specific data record was used during the training or not. So let's talk about membership inference attack on knowledge graph. A membership inference attack tries to answer one simple question: was this data used to train the model or not? In this case, a knowledge graph, the data can be an entity or a relation or a triple. For example, Alice worked at company X. First, there is a target model, as we can see. This is the real model that the attacker wants to attack. This model is trained on the private knowledge graph, and the attacker does not know exactly the training data of the target model. So the attacker creates a shadow data set. This shadow data set is similar to the real knowledge graph, but it's not exactly the same. Then the attacker trains a shadow knowledge graph model on this shadow data with the same uh, type of model of knowledge graph, and the goal is to make this shadow model behave like the target model. After that, the attacker used the shadow model to collect examples. Some examples were used during training, so they are called member. And the other samples were not used during training, so they are called non-member. Finally, the attacker gives the output of the target model to the attack classifier, and the attack classifier tries to predict if a specific entity or relation or triple was part of the target model in training data. In this paper, we focus on the task of link prediction. It's not for entity, but so we are looking if this relation was in the data set or not. So membership inverse attack are really harmful to this type of graph. So our proposed model protects the knowledge graph model from membership inverse attack. First, the target knowledge graph model gives the class the probability. Then we added an LLM-based model after those class of probability, and this LLM does not answer like GPT or anyone answer questions, but it's inside the model, and the role or the main role is to change the cluster probability and make them safer, so the attacker cannot easily know if a triple was in the chain or not. So we propose three approaches. The first one is LLM guided knowledge distillation. And in this approach, we use a teacher model and a student model. Teacher model is trained first and gives class probability. The LLM-based model takes these probabilities and makes them softer and safer. And after that, the student model learns from these modified probability instead of learning from hard levels only. This helps the student model avoid overfitting to the training data, and as a result, the final model gives less sensitive output, and it becomes harder for an attacker to know if a specific link was during this training, in the training phase. So the second approach is LLM secured aggregation, and in this approach we train several knowledge model instead of using only one model. Each model gives its own class probability for the same entity or triples. Then the LLM-based model combines this output in an intelligent way. It does not just calculate a simple average; it studies the different prediction and creates a safer final probability distribution. This makes the output less dependent on one single model and has strong membership signals. And finally, the last one, the third one, is LLM-guided noise injection. In this approach, we add noise to the class probability during the inference phase. However, the noise is not just a random noise in a simple way. The LLM-based model looks at the output of the knowledge graph model and decides how to add smart noise. So the goal is to make the probability less clear for the attacker while keeping the correct prediction class as much as possible. So for the experiment setup, we have used 5 datasets as mentioned with all the information, and we employed 4 knowledge graph models. And we utilize 2-layer architecture across the following uh, shadow model and target model. They are trained into 20 epochs. So in this part, for the results, as we can see, we evaluate our 3 LLM defense. So the evaluation is done on 5 knowledge graph data as mentioned before, and tested in 4 knowledge graph embedding models. The objective is to reduce the accuracy of membership inference attack. A lower attack accuracy means better privacy, so random guessing is around 50%. So a difference closer to or below 50% is considered strong. Without protection, the attacker accuracy can be very high, around 96%. In many cases, after applying our LLM with the defense, the attack accuracy becomes much lower. So as we can see, in several cases, the attack accuracy becomes lower than 48%, and in some cases 42.8, and even 40.9 on FB 15K 2037 dataset. So in this part, we compare our 3 LLM guided methods with previous defense techniques. The compared methods include shuffle encoding, dropout, one-hot encoding, AU encoding, drop K, variational autoencoder, graph perturbation, one is Jiao, and variational graph autoencoder. So the results show that our proposed method gives the better protection against membership inference attack. In some cases, our methods reduce the attack classifier around 50%, which is better than many previous approaches. For example, classic methods often keep the accuracy around 50 to 60%. Some like review, K, and dropout. And among these 3 methods, we can see that knowledge distillation gives the strongest protection. After that, we have secure aggregation that comes second, and the third one is noise injection. So in this part, we study whether our difference damage the normal performance of knowledge model. As we have mentioned before, the task here is link prediction. So we should uh, take in consideration this task. So this is important because a good defense should not only protect privacy, it should also preserve the task of the model, which is link prediction. So the results show that our 3 LLM graded method preserve the model accuracy very well. They protect the model without causing a large decrease in performance in prediction performance. In contrast, some previous defense methods reduce the accuracy of the knowledge graph. For example, dropout cause an accuracy decrease between 30 to 40%, and you can see also the variational autoencoder between 7.5%, and for graph perturbation is 22%. So we see that there is a lot of loss of the accuracy of the task, the main task, which is link prediction. Therefore, our LLM guided defense gives a better balance between privacy and utility. So, in conclusion, our methods reduce the attack risk while keeping good prediction accuracy compared with classic defense like door pouch, variational encoder, graph autoencoder, and others. Our method gives strong prediction and richer stability. And among the three approaches, knowledge distillation gives the best results because it projects the model without reducing its performance. So, in future works, we plan to test our LLMs beyond GPT-4 because the chosen one that we have chosen in this work for LM was GPT-4. So we'll look for other LMs to make comparison and study more knowledge tasks, not just for like relation prediction, maybe on entity or and other tasks, and improve defense by protection both posterior plus probability and the model architecture. So that's it, and thank you for your attention.
Okay, thank you very much. Any questions? Okay. Can you just tell us a bit more about your assumptions, your architectural assumptions about the possible attacks? Because you've talked about knowledge graphs. Of course, it's a well-known concept in terms of abstract concept, but in terms of the architecture, the supporting architecture where the knowledge graph is represented and addressable and accessible, what are your assumptions when you talk about knowledge graph attacks?
For knowledge graph tasks, so do you mean this the architecture of the proposed approach, or just in general what's the task of knowledge graph and how it works?
Sorry, can you repeat again, please?
Just about related to the question, are you asking about the main task of knowledge graph, like
Okay,
entity
you have this knowledge graph which you are now showing, okay?
Yes.
Of the supporting architecture, is that like an open architecture you are assuming, or some sort of centralized system or distributed system? What is your assumption about the supporting architecture, where the data is stored and accessible?
I see. So the complexity of the main problem is like here we have a relation, for example, between James and Lily, and we have a link is a friend of. So the attacker, what he can predict or assume is like prediction if there is a link is a friend of is or is there is a link between these two entities or not. So for the storage, what we have is working just in local, especially in environment on Google Colab. We were working just in cloud, and but we don't work in a private data. We are just working on public data.
Okay, thank you very much.
You're welcome.
So we're now moving to our fourth presentation. I believe Michel Paredes is ready to present, right? Hello, Michel.
Hello.
So when you're ready, you can start sharing your presentation and start your presentation. Excellent.
I screen my.
You can begin.
Good morning, everyone. My name is Michelle Paredes. I am from Universidad de las Fuerzas Armadas ESPE in Ecuador. Today, I'm pleased to present our paper entitled Mobile Test Pro a Real-World Evaluation. This work was carried out together with Professor Danilo Martinez, Mireya Zapata, and Marcelo Real. During, the, during this presentation, I will introduce the background of the research, explain the problem, present your objectives and methodological, discuss the main result, and finally present your conclusion. Let me begin, Let me begin with the background of the research. Mobile devices have exponentially grown so over the last 2 decades. Today, they are the part of the daily lives, and people use mobile applications for communication, entertainment, education, and many other activities. Since the launch of the iPhone in 2007, the application development has changed significantly as applications become more complex. Development need better methods to ensure a software quality. On the of the most important activities in software development is testing. Testing helps developers verify that the application works correctly and also evaluates important quality aspects for performance, security, accessibility, compatibility, and energy consumption. In this context, Romero Collaguaso and his colleague proposed Mobile Test Pro, in a framework designed to evaluate different quality dimensions of mobile application. This leads us to the main problem addressing your research. After introducing Mobile Pro identified an important limitation, Mobile Test Pro was proposed a framework that integrates different quality dimensions for mobile application. These dimensions include compatibility, performance, security, accessibility, and energy consumption. However, this initial validation was carried out of science to application. To application are ensured of testing new ideas because they are simple and easy to follow. However, they do not present the compatibility of real mobile application used by millions of users every day. Because of the limitation, important question remains: can mobile test pro effectively evaluate real-world mobile application? To answer the question, we say to validate the framework using popular mobile application for different contexts. After identifying the problem, we identify the types of research. The main goal of this study was to evaluate the mobile display in the real world environment and determine its impact on the quality mobile application. To achieve this goal, we first analyzed the mobile display framework and these quality dimensions. Then we set this plan based on those dimensions and applied it three more three popular mobile applications in different real-world contexts. Finally, we aligned our result to determine whether Mobile Pro is effective framework to evaluate the quality of mobile application. To evaluate the mobile application, we conduct a case study following the data by Runison. A case study is a program method because it also as study phenomena in the real world context. We adopted a holistic multiple case study based on the approach proposed by Robert G. Three application contexts were selected: video streaming, social media, and communication. These unique analyses were YouTube, Instagram, and WhatsApp. Next, we designed the tech plan on the quality dimensions defined by White Pro. We applied the test plan to each application and collect the results for analysis. After applying the test plan to the three mobile applications, we insight to result optimized for each quality dimension. Overall, the results showed clear resi- relationship between the evaluated dimensions. First, certificate accessibility ensure maintain the colors, construct, and the size to touch element. Second, the three tests show the some application experience performance duration with Borland script. We also identified important security vulnerabilities such as the traffic communication and explorer components. And finally, we observed that hybrid system load was associated with higher data consumption. These finds demonstrate the mobile application can identify quality issues in real mobile applications and provides all useful information for improving software quality. To conclude, the result initiative, the Mobile Pro is an effective framework for evaluating the quality of mobile application in the real world environment. By applying the framework to three different apps and contexts, we were able to identify important quality ensure relate to accessibility, performance, security, compatibility, and energy consumption. The result also showed that my mobile application provides a structured and systematic way to evaluate mobile application, making it useful for both on academic research and software development industry. As futures work want to expand the evaluates include more mobile device and additional application models. We also plan the very different application versions to analyze software quality develops uh, over over time. Thanks, thanks you for thanks you very much for your attention.
Okay, thank you very much. So, any questions about this presentation?
No,
Let's see.
Good evening. Hello, everyone.
Yes.
I am Danilo Martinez professor, and I am a part of the research for the paper. Michelle,
Okay.
one question: why you choose the use case to for your research?
Michelle?
yeah, okay. We chose a case study because they wanted to evaluate a mobile display in real world environment. Case study allowed to observe how the framework performance in real mobile application insert and they collect on situation similar environment. We follow the white lines proposed for Runderson the holistic multi-case and study approach proposed for Jim.
Okay, thank you very much. So, if there are no more questions, okay, so we'll move to the next presentation. So now I believe we have Miguel Cunha for the last presentation.
Yeah.
So welcome, Miguel. You can share the presentation with us, and once you're ready, you may begin your presentation.
Okay, thank you. Are you guys seeing?
Let's wait just a moment. Not really. Not
Let me
working.
see. Try again. Are you guys seeing now?
No, that might be an issue with your internet connection, perhaps due to a firewall or something that already happened. Do you have the chance to connect with a mobile hotspot, for example?
Let me try fix this here. Okay, are you guys seeing now?
No, still not working. Julio, can you explain a bit more what may need to be done?
Miguel could try to connect through a mobile hotspot instead of the connection he's using. We already experienced that some connections with their firewall block some functionalities. So switching to a mobile connection which doesn't have any firewall perhaps could make it work.
I'm gonna try here. Let me see.
Can you hear me when I'm talking?
Yeah, I can hear you.
Okay, perfect.
I'm gonna try to enter with my cell phone here.
Yes, please.
Okay, we'll just give Miguel a moment so we can try to sort out this issue.
Oh, sorry guys, I'm gonna try here. Let's see.
But my question is, let me see. My question is how I'm going to share with you my work, transmute, share my screen.
So if it is not working also via mobile hotspot, maybe you could send slides via email to the chairman and ask him to follow the slides for you.
Okay. How I send?
Okay, so let's check. The thing is that I'm not on the main computer.
Or you can also send them to me.
Okay.
My email is type it in the chat.
I'm gonna send you.
Marina is here at the computer. Can she help getting the presentation there?
You can send the presentation to me via email. I put my address in the chat of the room.
Okay, then you share it by yourself from your computer, right? Is that the plan?
Okay, I sent to you.
Diretamente a partir da ligação deles. Se calhar se precisar.
You received?
Are you sending them to me?
Yeah.
So I haven't received it yet.
What?
I haven't received the presentation yet.
Acho que só receber a apresentação.
Let me check. Júlio Bom, my email is Miguel Pinho BJJ.
Acho que eu vou conseguir saber. Sei que eles precisam ter livros novos.
Não, eles conseguem.
Para diretamente os amigos.
É isso.
Didn't receive?
No, didn't arrive yet. Could you type your email address? Okay, now it arrived.
Okay.
Just allow me 1 second to download it. And open it. Right.
Okay, that looks good.
Okay.
Can you
So
see?
guys, yeah.
Okay, so just tell me next slide when you want me to change slide. Okay.
Okay.
Julio,
Okay, perfect.
you can close that window on the left with the chat. Is that yours or?
No, it's not mine.
Okay. It should be
I
from.
think it's on the local PC.
You see it?
No,
Oh, okay.
online it should be visible.
That's fine.
You can just close it on the PC in the room.
Yeah, that's fine. Okay, it's okay. Okay, Miguel, if you're ready, you can begin.
Okay, sorry for that. I didn't know that this can occur. So let's start finally. So hello everyone. Hello Rui. Good morning. My name is Miguel Cunha, and I am from the Federal University of Rio Grande in Brazil. And today I will present the paper titled LEAP, Liquid-Free Evolutionary Alpha Pipeline for NLP-Driven Dow Jones Industrial Average Prediction. So this work was developed with my co-authors from FURG-Unesp and UNRV. You can pass the slides, please.
Yes.
Okay, so our problem focuses on forecasting the daily directional movement of the Dow Jones Industrial Average. So for do this, we analyzed a continuous series of almost 2,000 trading days from 2008 to 2016. So we have 8 years of data. However, our research addresses a specific statistical financial gap. In financial forecasting, traditional metrics like AUC treat all misclassifications as equally costly. This is problematic because it ignores fat tail events, the high magnitude movements that are crucial for profit. So our objective is twofold. First, to build a liquid-free pipeline that preserves chronological integrity, and second, to shift the paradigm from symmetric statistical evaluation to magnitude-aware training, ensure that our model's performance reflects real trading viability. You can pass the slide. So our LEAP framework is designed to ensure a strict scientific rigor. First, regarding data integrity, we implement a strict chronological split with a 70% for training, 15% for validation, and 15% for testing. Crucially, we compute our normalization statistics exclusively on the training partition, ensuring no future information leaks into the test set. Second, we address overfitting through evolutionary optimization. So for do that, we use this fitness function that you guys can see, where the product involving lambda acts as a regularization parameter. By setting this lambda to 0.5, we explicitly penalize the generalization gap between the training and the validation sets. And finally, our cost-sensitive learning approach uses a wage factor of 2.0 for the most significant 25% of the market moves. This forces the model's loss function to prioritize high volatility fat tail events over the noise of the low magnitude days. So you can pass. So the core of the work is here. I think the core of the work is here. So the LEAP pipeline is organized into a modular architecture to ensure maximum experimental rigor. In our data acquisition layer, we process multimodal inputs, combining firmware-derived sentiment embeddings with 39 price-based technical indicators. So moving to the core pipeline, we apply a liquid-free feature selection using RF AECV, ensuring that all transformations respect the temporal structure of the Dow Jones data. Then our optimization engine uses a genetic algorithm to explore the hyperparameter space. And finally, we implement a dual perspective evaluation. So we don't just measure statistical discrimination throughout AUC, as we also validate our models via a financial backtest, generating cumulative alpha to prove real trading probability viability. Pass this slide. So our feature engineering process maps raw inputs to a 109-dimensional feature space, ensuring a multimodal representation. We integrated 3 core components, as you guys can see. So it's the sentiment signals, technical dynamics, and multi-scale temporal lags. Specifically, we calculate these lags from 1 to 20 days to capture the market's autocorrelation structure. And to refine our sentiment input, we implement a Hank-weighted attention mechanism. We create this because we believe investors prioritize top-ranked news. So we apply an exponential decay function to give more weight to the most impactful headlines. And finally, we choose firmware tone, not only for its financial vocabulary precision, but it's for its high competition efficiency. Can pass. So with this amount of features, we have to do a reduction of them. So to mitigate this, we employed recursive feature elimination with cross-validation. So we use a 5-fold time series aware cross-validation scheme to preserve the chronological integrity of the data. Using gradient boosting as our basic estimator, the algorithm iteratively from the redundant variables. So after that, we have an optimal subset of 21 features. You can pass. So now to address the overfitting trap, where traditional tuning tends to memorize the market noise, we deployed a genetic algorithm for hyperparameter optimization. So here, our core innovation is the penalized fitness function. So the term, as I explained in the beginning, the term with the lambda, he acts as a regularization mechanism. So it forces the algorithm to penalize any model showing a significant generalization gap. Can you pass? Here is just a comparative performance analysis between genetic algorithm and grid search. As you guys can see, the metrics of the grid search are really great in the train and the validation set, but in the test set with data that the model never seen before, he performed really bad. So that's why we choose a generic algorithm uh, to this work. Can pass. So here is the real test. So now we evaluate our LEAP framework's performance using our cumulative wealth formulation with this formula here. For the gradient boosting model, we observed that he had a test AUC of 0.5, which sits slightly above random. So the model, as you guys can see in the graphic, the model adopted a highly conservative behavior, which was key to avoiding catastrophic drawdowns during periods of high market uncertainty. And we have a alpha generation. Uh, uh, we have this conservative logic successfully outperformed the binomial benchmark by 1.69 percentage points in alpha. You can pass. So here is the the main point of the work. So here we present the core paradox of our research. The MLP model demonstrates a statistical financial divergence, where the model yield a test AUC of 0.48, which traditional evaluation would be a failure. It actually delivered a massive alpha of 13 percentage points. So this paradox, of course, because our training object was cost sensitive. We penalized the model for missing high magnitude volatility events, effectively forcing it to ignore small price fluctuations to capture the fat tails events. Okay. So in conclusion, our research suggests that symmetrical statistical metrics like AUC and accuracy may not fully capture the economic nuance required for robust trading evaluation. And moving forward, our research roadmap focuses on three main pillars. So first, we plan to evolve our cost-sensitive learning by implementing a continuous weighting framework based on intraday volatility Z-scores. In the second place, we aim to integrate high-frequency intraday dynamics to capture finer price trends. And finally, we will explore advanced sequence NLP architectures to better model the long-term temporal dependencies of the global news flows. So, can you pass? Thank you everyone for your time, and sorry for the beginning.
No problem. Thank you, Miguel. So, are there any questions to Miguel? Not here in the room. Anyone else? Okay, so that concludes our session. I would like to thank all the presenters for their presentations and their work. So thank you very much and see you in the other sessions. Bye-bye.
Thank you. Bye.
Thank you. Goodbye.
Bye-bye.
Bye-bye.
Claro, sim, que lugar mesmo.
Sim, é só. Ai, estas não tem. Tem, eu. Mas eu não gostava nestas. Isto. Claro, chuva. Mas pronto, é tirar a oportunidade. Se quiser vir hoje, para comprar, deve ser.